Have you ever noticed how a single new piece of information can completely change how you see a situation? Well, it's not just a feeling, it's actually a mathematical reality. We're going to dive into exactly that, how learning something new can fundamentally and predictably alter the odds of an outcome. So let's start with a bit of a puzzle. Can the probability of something happening actually change after the whole thing is already in motion? It kind of feels like it shouldn't, right? The coins are flipped, the dice are rolled, but the answer is a huge, definite yes. And understanding how this works is one of the most powerful ideas in all of statistics.
All right, to really wrap our heads around this, we're going to use a super simple classic experiment. We're just going to toss 3 fair coins. That's it. No tricks, just pure probability.
Now, when you toss 3 coins, what can happen? Well, there are exactly 8 possible outcomes. You could get all heads, you could get all tails, or some mix in between. Each one of these is equally likely. So think of this list as our entire universe of possibilities. Everything that could happen is right here. Okay, first question for you. Before we know anything else at all, what are the odds that we get at least 2 heads out of our 3 tosses? So, if we just count them up from our list, we find 4 outcomes that work. All 3 heads, or any of the 3 versions with 2 heads. So 4 favorable outcomes out of 8 total possibilities, that gives us a probability of 4 out of 8, or a nice clean 50%. Easy enough. This is our baseline, our starting point. But here comes the magic trick. We're about to get one little piece of new information, and I want you to watch what it does to our universe of possibilities. So imagine this. The coins are tossed, they're hidden from view, but a friend peeks and tells you just one thing. The first coin landed on tails. That one single fact is a total game changer. Because with that new information, our original universe of 8 outcomes, it just collapses instantly. Any outcome that started with a head is now completely impossible. It just can't happen. So we're left with a brand new, much smaller universe of only 4 possible realities. So let's ask our question one more time. But now, living in this new, smaller world where the first coin must be a tail, what's the probability of getting at least 2 heads? Well, look at our 4 remaining possibilities. Only one of them, THH, has at least 2 heads. The probability just plummeted from 50% all the way down to 25%. The odds literally changed right in front of us just because we learned something new. Now, this whole intuitive idea of a shrinking universe is really cool, but it also has a formal name in mathematics, and it comes with a seriously powerful formula that lets us calculate these changes precisely, every single time. What we've just been playing with here, it's called conditional probability, and it is honestly one of the most useful concepts in all of statistics. Yep, conditional probability. The notation looks a little formal, P, then E with a vertical line, then F, but you just read it as the probability of E times given F. For our coin toss, it was the probability of getting at least 2 heads, given that we knew the first coin was a tail. And here is the engine that makes it all work. The formula says the probability of E given F is simply the probability of both E and F happening together divided by the probability of F just happening on its own. It's really just a mathematical way of saying, okay, let's only look at the world where F is true and then see how often E also happens inside that little world. All right, enough theory. The absolute best way to really get this is to see it in action. So let's put this formula to the test with a couple of classic problems. Okay, here's a classic brain teaser that trips a lot of people up. A family has 2 kids. You know for a fact that at least one is a boy. So what are the odds that both are boys? Now, your gut might be screaming 50%, right? But let's see what the formula tells us. Let's just walk through it. Our given info, event F, is at least 1 boy, which leaves us with 3 of the 4 possibilities. Our target, event E, is both boys. The formula takes the probability of the intersection, both events happening, which is 1/4, and divides it by the probability of our given event, 3/4. The result, 1/3. Knowing there's at least 1 boy changes the odds from 1 in 4 to 1 in 3. Pretty wild, huh? Okay, let's do one more, a quick one. We draw a card from a set numbered 1 to 10. We get a clue. The number is greater than 3. What's the new probability that the card is an even number? We just apply the exact same logic. Our condition, the card is greater than 3, shrinks our universe from 10 cards down to just 7. Now, inside that new, smaller universe of 7 cards, how many are even? Well, we've got 4, 6, 8, and 10. That's 4 of them. So the probability is simply 4 out of 7. See?
Once you get the hang of shrinking the universe, it's pretty straightforward.
So, this might all seem like fun little games with coins and cards, but this single idea, it is a massive cornerstone of how we make sense of a really complex and uncertain world. I mean, this isn't just theory. This is the exact logic that powers some of the most important systems around us. It's how doctors update the likelihood of a disease based on a lab result. It's literally how machine learning algorithms learn from new data and get better at their jobs. It's how people in finance adjust their forecasts based on a new economic report. And really, it's how you, intuitively, update your own beliefs every single time you encounter new evidence. You could say conditional probability is, quite simply, the mathematics of learning.
As the philosopher Charles Sanders Peirce brilliantly put it, probability isn't just about math, it is the science of logic quantitatively treated. It's about turning logic itself into numbers. And conditional probability is the rulebook that tells us how to reason logically when we're faced with new facts.
So, we'll leave you with this thought. You now have the formal tool for updating your beliefs with evidence. The only question is, what are you going to use it for? What odds in your own life will you start to recalculate?